The sum of the length, breadth and height of a cuboid is 19 centimeter, and the sum of the areas of its three adjacent faces is 130 square centimeter. Find the length of the longest rod that can be placed inside the cuboid. So we have a cuboid, and it's given that sum of the length, breadth and height of the cuboid is 19 centimeter, and also the adjacent sum of the areas of the three adjacent faces is 130 cm. So let us visualize the cuboid first. Suppose this is the cuboid. Suppose, okay. Let's imagine a cuboid like this. Then it is said that we have length, breadth and height. Suppose LBHR, length, breadth and height, and the summation of length, breadth and height, length, breadth and height is how much? It is 19 cm. Okay, 19 centimeter. Also, sum of its faces. Suppose this is one face, the top face, one face, then this adjacent face, this is another face, and the side one, this is another face. So 1 2 3, three adjacent faces, 1 2 3. The summation of their areas is 130 cm square. So how do we get the areas of these faces? This one is length into height, because this is height, you can see length into height, right? This one, so length into height, plus this one is breadth into height, breadth into height, plus, and this one is length into breadth. Okay, this one, this is length, this is breadth, so length into breadth. This is equal to how much? 130 square centimeter. This is equal to 130 length into height, breadth into height, length into breadth. This is equal to 130 square centimeter. 130 square centimeter. So these are two equations, okay, we get from this cuboid, from this problem. So we have to find the length of the longest rod that can be placed inside the cuboid. Now, what is the longest line that can be placed inside the cuboid? We know that the length of the longest line that can be placed inside a cuboid is the vertex, the space diagonal. It is the space diagonal. Okay, the length of the longest the length of the longest straight line that can be placed inside a cuboid is the space diagonal. The space diagonal is the longest line, longest straight line that can be drawn from one vertex to the opposite vertex. So naturally it will represent the length of the longest rod. Okay, so if we find the length of the space diagonal from this point to this point, or from this point to this point, or from this point to this point, opposite vertex, if we join them we get the space diagonal. So anyone will do. So we take this space diagonal from this point to this point. So if we find the length of this space diagonal, we find the length of the longest road. So we already have these equations, and based on these equations we can find the value of this diagonal, length of this diagonal. So what if this is length, this is breadth, this is height? What is the formula for this space diagonal? It is, suppose D is the diagonal, then it will be equal to length square plus breadth square plus height square. So this is the formula for the length of the space diagonal or the diagonal inside the cuboid. So we have to find the value of this one with the help of these two equations. Okay, that is the solution. That is how we have to solve it. So to solve it, let us just draw a line. This is for illustration purpose only, you don't have to write this. Okay, if you want, you can draw the diagram, but don't forget to label, give it the label. L means length, breadth is B means breadth, and H is height. Okay, and don't forget to draw the diagonal also if you want to show the diagram, that is. And if you get the marks are given say 4, and if the marks are say 4 marks or 5 marks are given, then you can include this diagram. Otherwise you can just write the solution here. So let us write the solution. Okay, usually such questions are of 3 marks or maybe maximum 4 marks. So for that you don't have to draw the diagram. So let us write the solution. Let the length be breadth, sorry, this is length L, this is B, height, suppose it is H. So we have L, B and H. So it is given, what is given? Length plus breadth plus height. The sum of the length, breadth and height is 19 centimeter. So this is equal to 19. Okay, so we get equation number 1. Then sum of the areas of the 3 adjacent faces is 130. So how much we got? Length into height, breadth into height, length into breadth is 130. So that will be the second equation, 130. This is equation number 2. Now length plus breadth plus height square, if you square it, what do you get? This is the formula, algebraic formula. This is length square plus breadth square, sorry, breadth square plus height square plus twice LB plus BH plus LH. Okay, this is the algebraic formula. L plus B plus H is L square plus B square plus H square plus twice LB BH plus LH. That is A plus B plus C whole square formula. So the value of this formula is this one. Okay, left hand side is equal to right hand side. So look it up if you don't know it already. So this is a formula, you have to remember this formula. So Now we substitute the values. What is L plus B plus H? It is 19 from equation 1. We don't know L square plus B square. 19 square is L square plus B square plus H square plus twice. What is LB BH LH? This one. This one is equal to this one, 130. So we get 130. Okay. So that means 361. 19 into 19, 361. This is equal to L square plus B square plus H square. This is 260. 2 into 130 is 260, which means L square B square plus H square is how much? 361 minus 260. 361 minus 260, which is equal to 1, 0 and 1. Okay. Hence, if we take square root of both sides, L square plus B square plus H square is equal to square root of 101. Okay. But what does it represent? Length square plus breadth square plus height square. What does it represent? It represents the value of the length of this diagonal. It represents the length of this diagonal from here to here. It represents, so this value represents the length of this diagonal, or this space diagonal, or the diagonal, simply diagonal. Okay. So it also represents the length of the longest line that can be drawn inside the cube, and hence it also represents the length of the longest road that can be inside the cuboid. Fine. Hence, length of the longest road that can be inside the cuboid is this one, square root of 101, and don't forget the unit, cm. Okay, so cm, this is important. If you don't give the unit, your answer may not be accepted. So this is how we find the longest road given summation of length, breadth, height, and area of the three adjacent, summation of the area of the three adjacent sides. Okay, and don't forget this formula. You have to use this formula. This is important. Remember this formula. It is a plus b plus c whole square formula. A plus b plus c whole square is a square plus b square c plus c square into 2 into a plus b, b plus c, c plus a. This is algebraic formula. So remember this formula. It will be needed to solve this problem.